So let's start with a poll that I was going to take yesterday. First, I need some information from you before I can conduct the poll. So we've had 4 different types of statements we've learned over the course of this year. Can anybody give me a category of geometry kind of statements we have studied? Postulates. Postulates have been learned by us. Somebody else?
Theorems.
Theorems have been learned by us.
Properties.
Properties have been learned by us.
And then definitions.
Definitions have been learned by us. Then we'll take a poll. Which of these do you think we have the most of right now? Before we read 4-6, I did my count up through and including 4-5, not including 4-6. What do you think is the champ of we have had the most of these things?
Postulates.
We're going to come around. Everybody will get a vote.
I think it's between properties and postulates, so properties.
So you're going to say properties. You're going to say theorems. You're going to say theorems.
I'm gonna say theorems.
You're going to say theorems. Theorems.
Theorems.
Theorems.
Postulates.
Postulates. Postulates.
I'm just gonna go definition.
You're going to get that just to be contrary? Because you were ready to vote postulates a minute
I
ago.
mean, I thought it over and I was like, it's definitely not postulates.
Reconsider.
Yeah.
Definitions.
I was out
What are definitions?
You're going to go definitions.
Theorems.
You're going to go theorems. Not very many people are right. And the contest is not even close. There's one category that has more than the others combined, plus like 10. Okay. So here's our counts at the moment. In last place are the theorems. We have had a grand total of 11 theorems to this point of the year. Why can't we have had very many theorems?
We just started. We didn't do proofs.
We didn't do proof. A theorem is a statement that you need to prove, and you don't know how to do proofs. So they can't have done too many theorems. Postulates are second to last. Postulates is 12. Postulates are, 14. We've had 14 postulates, so that's in second to last place. Properties, there's been 15 properties. Addition property of equality, transitive property, that kind of stuff. There's 15 properties. Definitions, there's 51. Everything that's been a blue italic word has been a definition. How many blue italic words?
A lot.
Oh, I mean, tons and tons and tons and tons of them. Okay. So yesterday we had a lot of trouble doing 7, which is understandable. We always do. I get it. We talked our way through that homework question 7, where we were trying to supply a postulate, a theorem, a property, a definition. Almost every time we stalled out, what were we indeed looking for?
Definition.
Definition. Okay. So you were trying last night on that page to do 8 and 9. If you had stuff you like just stalled out on 8 and 9, probably what you're looking for
Definition.
is a definition. Okay. The definitions are by far going to be more common than anything else. There really aren't any more postulates, very many more postulates coming. I think we get up to like 20-ish in the year. Theorems are going to start flowing. The properties pretty much are done. Definitions will continue to flow. So I doubt if theorems will ever catch definitions with the lead that definitions has accumulated. But by the end of the year, theorems will surge into second place. Theorems will probably end up, I don't know, might hit 100. I don't know that they'll hit 100 or not, but they might. The properties will still probably be sitting at 15. The postulates, there might be 20. Definitions might, 150, 200, who knows? That's going to be a lot. But there's a moral of the story there. When in doubt, think definitions if you're trying to search for a word. Question about that concept? Yes.
Are we gonna have to know all 200 definitions for the last test?
No. You'll need to know the more important of the definitions. There will be a final exam and the stars will be on there. But some of the ones you know will be on there. So in your hands you have a second sheet. Let's do the 4-6B paper. The 4-6B quiz preview. Let's talk them through. So The quiz is gonna shrink, but then it'll grow again. The 4-7 quiz will be bigger than this. The 4-6B is just the bigger highlights of the chapter so far, and then some of the medium lights will return on a 4-7 quiz someday, but more about that some other day. 14 is the one we talked through yesterday in great detail. Let's work that out again. We're at a point of the year where the reading should do one of two things for you. Well, one of two things you can do with the reading. One is, as you read it, you should try to think, does this make sense? Could I explain this based on math I know? And if the answer is yes, you're doing little mini proofs in your head, and that's good. If you can't do that, at least think, even if I couldn't explain it, does this like work for me? And if that's a yes, that's good. If not, then wait for class and hopefully we clean some stuff up. Another thing you have on the quiz, if you mind blank the memory part of this, I'm not asking you to memorize all this stuff all the time. You can draw your way out of trouble a lot, and you can think your way out of trouble a lot now if you know the other words. So like 14, we could think our way out of trouble, and we'd already did this yesterday. If I start talking about a linear pair, we should know if things form a linear pair, then they're supplementary. We should know that supplementary means
180.
180. We should know that congruent means they're the
Same.
same. If there's two things the same that are 180, basic math should tell us they're each,
Over again.
skip one step, a 90, and 90 is called a
Right.
right angle. So 14, even if you don't memorize 14 well, you might be able on the spot on a quiz to figure out it's a right angle. Or if you're reading that at home and think, linear pair making right angles, does this make sense? If you jump through all those hoops, it makes sense. 15, you could maybe make sense out of it. Complementary means together two angles make
180.
90.
90. So if together they make 90, as a standalone individual, they'd have to be
45.
not necessarily 45,
Just the cube.
they'd have to be acute, because the acute means that they're
Less than
less than 90. So if together they're 90, as a standalone, they'd have to each be less than 90 somewhere, so they'd be acute. So when you read that in the reading, if you think to yourself, does that make sense to me based on things I've learned before? Hopefully the answer is yes. If not, you show up. I try to explain why it does make sense based on things we've had. Theorem 4.4, today was a fill in the blank. This is our first theorem that we're going to do by number. They didn't give this one a name. Almost every theorem we memorize will be one that has a name, but there's a couple that have numbers. So theorem 4.4 is going to tell you that any two right angles are filled in the blank today. What was that? Congruent is correct. So if this is a right angle, and this is a right angle, if this is a right angle, it measures
90.
90. And if this is a right angle, it measures 90. How do you know that? Definition of a right angle. If this equals 90 and this equals 90, they have to equal each other. What property is that? This equals 90, that equals 90.
Property of-
So they equal each other.
Property of like congruence.
It's the one, how many items did I just mention? This equaled 90, that equaled
Oh, it's
90,
symmetric?
so they equaled each other.
That's the one above
Reflexive?
symmetry. It's
How many things did I just mention?
2.
No.
one.
No. This equaled 90, that equaled 90. They equal each other.
Oh, transitive.
How many things did I mention?
3.
This, that, and,
They each other.
yeah, who else did I mention though? Twice. 90. 90's what like put them together. So I did transitive yesterday, like if Asa has the same amount of money as Melissa, and Melissa has the same amount of money as Caleb, we have to know that
Asa's the same amount.
Asa has the same as Caleb. We compared three people using